Hello everyone, my name is Drew Cameron. I'm going to be introducing you to Group 17 and our secure messaging app, Firewall Friends. Our group consists of me, Felipe, Sarah, and Porter. And let me show you a little bit about what we're going to do. We are currently done with our research and design for our project, so we found the algorithm that we want to implement to encrypt our messages on our messaging app. Now we have a little more than a month to implement all of that. So by October 26th, we want to have implemented the algorithm, have the user interface complete, and have it in a space where we can iron out all the bugs. So November 9th is really where we start finding some of those bugs. That's our code security analysis. So we'll look and see if we can find any kind of vulnerabilities or exploits inside our implementation, and we'll have all of our bugs, anything that's wrong with the program, fixed by November 23rd. So that will give us a couple of weeks to work on documentation and the final reporting. So that's any demos, that's any presentations, that's any reports that we have to make will all be done by then to shine our project in the best light. I'll now pass it to Felipe to explain a little bit about our first milestone here.
Hello, everyone. My name is Felipe, and I'll be covering our progress for Milestone 1. Our group researched different secure messaging protocols, including the Signal protocol. From that, we decided to implement the Diffie-Hellman key exchange in our project. Diffie-Hellman lets two people agree on a shared secret key, even over an insecure network. Once both sides compute the same shared secret, we can feed it into a key derivation function to produce a strong encryption key. In our secret chat app, this key will be used with symmetric encryption algorithm like AES in GCM mode to encrypt all messages before sending. That way, even if someone intercepts the traffic, they won't be able to read the contents. We're also started planning how to handle poor input validation. Without proper validation, an attacker could send oversized messages or even malicious input that could crash the app. To prevent this, we'll enforce message length limits, sanitize special characters, and reject invalid usernames or inputs. So for milestone 1, we've accomplished the research and encryption and input validation, chosen Diffie-Hellman plus AES GCM as our core design, and we finalized our milestones and abstract based on this work.
Hi, I'm Sarah, and I'll be going over our project abstract. We're working on a secure chat application with an end-to-end encryption, and we decided to use the Diffie-Hellman method. To get there, we compared several encryption algorithms, such as RSA, AES, CSIDH, and the Diffie-Hellman. We also reviewed two academic papers. One broke down how apps like WhatsApp and Signal handle key exchanges and showed that if it's not done correctly, users are still vulnerable to attacks. The other paper compared different encryption methods side by side, which helped us see trade-offs more clearly. Together, those papers helped us make the call to move forward with the Diffie-Hellman for our prototype. When reviewing those, RSA uses two keys. One you share and one you keep private. It's strong, but a little heavier than we need. AES is a really fast, but the problem is you have to share the same key, which isn't as safe in our case. CSIDH is newer, post-quantum method. It's interesting, but it's still experimental and not widely used yet. Diffie-Hellman ended up being the best option for us. It lets two people create a shared secret without ever sending in the actual key. That means even if someone is listening, they can't read the messages. It's simple enough to implement, but secure, which is exactly what we needed for our project. So overall, Diffie-Hellman gave us the right balance of being practical to build and secure enough for the real-world messaging,